6.1, we are solving systems of equations through graphing. The vocab words that we need to be confident with is system. A system is two or more lines that may or may not have an intersection point. So if I say figure the system out, it means that there's more than one line. That's the layman's way to understand it. There is more than one line. A solution to a system. A solution is a point on a graph that satisfies both lines. That means it's true for both. It means that is their intersection point. Okay, because if I have this line going this way, and then this line going this way, on a coordinate plane, let's just make a coordinate plane, then I would say that my solution would be, when is it true? When is a point true for both lines? Well, it's wherever they intersect. Wherever they intersect, it's going to be true for both because it's on both of them. So a solution is really just an intersection point between two or more lines. I'm going to make this a little nicer. Okay, when I'm looking at these two graphs, and I say, what's a solution to this system of equations? Because there's two of them. So that's why I'm calling it a system. Well, the solution means, where is it true for both? What's a point on here that's true for both lines? And the only point that is true for both would be the intersection point. And in this situation, I would probably call that the point 2, 2. And that's how you answer it. The solution to my system is that intersection point, and you represent it like a point, 2, 2. We are going to be asked to find solutions or solutions to our systems. A system, again, means more than one line. In order to find solutions, our steps are to first make sure they're in slope-intercept form. That's the most important thing. We need to make sure that y is alone. The second thing we do is we graph both lines on the same coordinate plane. Lastly, we just determine where did we intersect. That is given as a point, so your answers will always look like this. Your answers will always be given to you like a point. All right, the next concept with 6.1 is checking solutions. And they're gonna give you a point and ask you to determine if that point is a solution to the system. A solution to the system just means, is it true for both? Would it be an intersection point? So how do we do it? We just plug into both equations and then see if it's true for both, okay? So I want to know, is 2, -1 a solution? That just means, would they intersect there? To the following system. 3x plus 2y equals 4. That's our first one. So I'm just going to write 3x plus 2y equals 4. You don't have to get it, if we're just checking solution, you don't have to get it in slope-intercept. I'd only get it in slope-intercept if I wanted to graph it. And again, I want to know the point 2, -1, that's my x, and y. So I'm saying, does 3 times 2 plus 2 times my y equal 4? Does 6 plus -2 equal 4? Does 4 equal 4? So it satisfies this equation. Now, I still can't say that it is a solution though, because it has to satisfy both. So now I need to put in my second equation, negative x plus 3y equals negative 5. And again, I have the point 2, negative 1. I'm checking to see, is that in common for both of them? Would that be the intersection point? So negative x would be negative 2 plus 3 times y is negative 1. Does that equal negative 5? Does negative 2 plus a negative 3 equal negative 5?
Yes.
Does negative 5 equal negative 5?
Yes.
Yes. So I would say 2, 1 is a solution. Now I want to give you a visual here. Your instinct might say, ooh, I should get that in slope-intercept form. And there shouldn't really be anything wrong with that, but notice what happens here. If I get this in slope-intercept form, I get 3y is equal to x minus 5, and then I get y is equal to x minus, 1x over 3 minus 5/3. Who wants to graph that? You don't want to graph if your y-intercept is a fraction, okay? So anytime they give you a point in two equations, you just want to plug the point in. All right, we're going to find the solution to this system of equations. First thing I'm going to do is graph both of them. I see that they're both in slope-intercept form, so I don't need to get them there. So I'm just going to go right ahead and plot that y-int on the first one, and then I go up 1 over 1, up 1 over 1, or down 1 over 1. Here is my line. Make sure you keep them as line, not line segments, okay? And then I have, on that second line, I'm going to do a different color. I had 3x minus 2, so my y-intercept is at negative 2. Then I go up 3 over 1, up 3 over 1, up 3 over 1. And it looks like my solution is right here. So my solution is 2 and 4. That is where they intersect. That would be the solution to my equation, to my system. All right, I want you to do another one. Okay, this next example, if I want to find the solution to this system, I have to look here and I see that it's not in slope-intercept form. So that's my step 1. The first thing I need to do is get them both in slope-intercept. So I have 2x minus y equals negative 5. I'm going to minus 2x. Then I have negative y is equal to a negative 2x minus 5. Now I'm going to get rid of that negative, so I get y equals 2x plus 5. That's my first line. My second line is going to be, I get negative 2x minus y equals negative 1. Add 2x, so I get negative y is equal to 2x minus 1. Change the signs. Y is negative 2x plus 1. Now I can graph them both, and again my solution is where they intersect. So I have a y-intercept at 5, 1, 2, 3, 4, 5. A slope of 2, up 2 over 1, up 2 over 1, or down 2 over, down 2 over. I try to extend my points a little bit more now that I know that I'm going to be finding intersection points. I usually like to do 2 in both directions. Okay, my next one, I got a y-intercept of 1, and then I go down 2 over 1, down 2 over, down 2 over. Am I ever going to meet it going this way? No, no, not going this way. So I want to kind of go backwards. I can go up 2 over 1, up 2 over 1. I found my intersection point. My intersection point is right here, and that is the point negative 1, 3. So my solution to this system, you just write it as -1, 3. It's where they intersect.